Hello, my name is Kimberly Montgomery, and I am going to be presenting some preliminary results from the data collection that took place this summer for my master's thesis. My project is focused on assessing source water contributions to streamflow in a Precambrian shield watershed in the Sudbury region, the Whitson River watershed. I would like to thank everyone who has contributed to this research and made it possible. The Whitson River project is focused on improving understanding of hydrologic function and groundwater surface water interactions in the Whitson River subwatershed. One research question derived is how much groundwater or surface water is in the streams at a given time throughout the watershed, resulting in the objective to understand how different end members are contributing to streamflow over space and time using stable water isotopes of delta O18 and deuterium and additional water chemistry parameters. The Whitson River watershed sits within the Vermilion River watershed, just north of the city of Sudbury. The Whitson watershed is approximately 328 kilometers squared in size, and the main stem of the river has a total length of 71 kilometers. To determine sources of water to the stream, all end members needed to be sampled. Surface water at different times of the year, precipitation, snow, and groundwater. Water samples were analyzed for stable isotope ratios of delta O18 and deuterium using a Picaro liquid water isotope analyzer. Synoptic surveys were conducted between June and November 2021. Biweekly sampling was conducted for surface water and precipitation samples, whereas groundwater was sampled twice in the Provincial Groundwater Monitoring Network wells and once for the municipal monitoring and pumping wells. In total, 223 surface water samples, 22 precipitation samples, and 20 groundwater samples were collected. Sampling locations span the watershed from headwater tributaries with varying land cover to sites along the main stem and including Water Survey of Canada gauging stations in Balcarron and Chelmsford. The results from the isotope analysis have an average accuracy from all runs for delta O18 and deuterium of 0.12 and 0.92 respectively, which are within acceptable limits. The delta O18 and deuterium values for all surface water samples were plotted based on the distance upstream from the outflow of the Whitson River. This shows the spatial distribution of isotopic ratios throughout the watershed. As the graph shows, there is variability in the samples. For example, along the main channel of the Whitson River, the samples are fairly consistent for all locations compared to the headwaters. Tributary 5 shows enriched samples, whereas Tributary 2 has a range similar to that of groundwater. The bivariate plots show the water isotopic composition in the Whitson River watershed. Precipitation samples fall along the local meteoric waterline, which is just above the global meteoric waterline. Groundwater and surface water also sits on the local meteoric waterline, but some surface water samples are below both the local meteoric waterline and the global meteoric waterline, indicating evaporative enrichment shown by the local evaporation line. The next steps of this project are going to focus on first collecting surface water samples during the ice-on period to properly do the mixing model analysis. Once this is done, we can calculate the percent contribution of end members to streamflow for all surface water locations in the watershed. Additional analysis of flow measurements and water chemistry are in process and will be used with the isotope samples to get a better understanding of groundwater surface water interactions in the Whitson River watershed. Thank you for listening to my presentation.